Good morning, students. Today we are discussing about the preparation of aromatic aldehydes and ketones from oxidation of arenes, hydrolysis of benzyl halides. Okay, arenes means we know that we discussed in previous class also. Arenes means specific structure which containing functional groups in ring formation, that is called arenes. Hydrolysis of benzyl halides means benzene structure. Okay, you know that benzene structure, okay, with containing halide groups. Okay, this is halide group, that is called benzyl halides. Okay, students, so we are discussing about preparation of aromatic aldehydes and ketones from oxidation of arenes and hydrolysis of benzyl halides. So first one, oxidation of arenes. Okay, first we are discussing about oxidation of arenes. The major methods applicable for the preparation of aldehydes and ketones are oxidation of aromatic hydrocarbons. First one, in the first one, oxidation of arenes, oxidation of aromatic hydrocarbons. The oxidation of aromatic hydrocarbons such as toluene. Okay, this is the toluene. The benzene ring which containing methyl group is called toluene. With manganese dioxide. Manganese dioxide means MnO2. And sulfuric acid, benzaldehyde. Sulfuric benzaldehyde means we know that sulfuric acid. You know that sulfuric acid means H2SO4. Okay, H2SO4. So to form benzaldehyde and aromatic aldehyde. Okay, benzaldehyde and aromatic aldehyde. First one we can take toluene. So toluene in presence of manganese dioxide and sulfuric acid to form that that is, so CH3, where CH3, this is CH3. CH3 in the CH3, manganese dioxide and H2SO4. H2SO4 means sulfuric acid. These two are combined. So these two are combined to form this CH3 convert to C double bond OH. That is called benzaldehyde. Okay, this is called benzaldehyde. Next one, third reaction. In this reaction, toluene is oxidized. Okay, this is also toluene. We can take toluene. So toluene is oxidized to aromatic aldehyde. Okay, aromatic aldehyde. Benzaldehyde in the presence of an oxidizing chromyl chloride. Okay, benzaldehyde in presence of oxidized chromyl chloride. The chromyl chloride oxidized methyl group. Okay, chromyl chloride is converted into methyl group to chromium complex, which on hydrolysis gives a product. Okay, first we can take toluene. So in the toluene, the presence of chromium chloride, chromium dioxychloride, and cesium. Okay, cesium in the presence of chromium dioxide to form chromium complex. This is the chromium complex. We know that complex. What is complex? This is the center atom which containing 4 or 6 octahedral or tetrahedral complexes. This is the complex. What is complex? We can take for example Fe. So this is the complex, or Fe. This is the complex. Okay, these two are complexes. So in that this reaction, toluene is oxidized to aromatic aldehyde, benzaldehyde in the presence of an oxidizing agent, chromyl chloride. Okay, this is the chromyl chloride. The chromyl chloride oxidized methyl group to chromium complex, methyl group to chromium complex, which on hydrolysis gives the product. So to form chromium complex in presence of hydrolysis to form benzaldehyde. What is benzaldehyde? The CH4 group or C double bond OH group which is containing benzene ring. It is called benzaldehyde. Okay. Next, Gattermann-Koch reaction. Gattermann-Koch reaction. In that Gattermann-Koch reaction, this is the most important question. Aromatic aldehydes can be prepared when arenes are treated with a mixture of carbon monoxide and hydrogen in the presence of anhydrous AlCl3 and a trace of cuprous chloride CuCl. Okay, this is the arene carbons or benzene in presence of carbon monoxide, in presence of hydrogen chloride. So in presence of AlCl3 and AuCl3 to form benzaldehyde and HCl. Okay, students, aromatic aldehydes can be prepared when arenes are treated with a mixture of carbon monoxide and the trace of anhydrous AlCl3. So the trace of cuprous chloride. Okay, cuprous chloride in presence of benzene, carbon monoxide and HCl, hydrogen chloride. To form the students, we can take this is the benzene and the carbon monoxide and the HCl. Okay, in presence of AlCl3, AlCl3 means aluminum trichloride or aluminum chloride, and that is some AlCl3 and Rm, mercury chloride. Okay, to form CH4 plus HCl. Okay, this is the structure. So first one we can take benzene in presence of carbon monoxide, in presence of hydrogen chloride, in presence of AlCl3 and mercury chloride. So to form benzaldehyde and HCl. Okay, this is the formation of Gadamer Koch reaction. What is that? Aromatic aldehydes can be prepared when arenes are, this is the arene. Okay, arene or benzene. Okay, students, arenes are treated with mixture of carbon monoxide and hydrogen chloride in presence of aluminum, anhydrous aluminum chloride, and a trace of cuprous chloride. This is cuprous chloride. Okay, CuCl. Okay, cuprous chloride to form benzaldehyde and hydrogen chloride. Okay, student, this is the Gadamer-Koch reaction. Next one, by side chain chlorination of toluene. Okay, that by side chain chlorination of methyl benzene forms benzyl chloride, which on hydrolysis gives aromatic aldehyde. Okay, students, in that first one we can take toluene. This is the toluene. Okay, the CH group which is attached with the benzene ring to form toluene. So in the presence of toluene, Cl2H2 to form CHCl2 in presence of H2O 373 kelvins. So CHO. Okay, this is the CHO. CHO means benzaldehyde. Okay, so first one we can take toluene in presence of chlorine and anhydrous chlorine to form what is methyl benzaldehyde. This is the chlorobenzaldehyde. So in the presence of this is the chlorobenzaldehyde in presence of H2O 373 Kelvin to form benzaldehyde. Okay, this is the benzaldehyde. Okay, students, by side chain means side chain chlorination of methyl benzene. Chlorination of methyl benzene means this is the side chain chlorination of methyl. Side chain means this is the ortho meta para ortho meta or para ortho meta para. Okay, this meta, this is side chain. It's called side chain also. Why? Because this is main chain. Okay, this is the side chain, this is also side chain, this is main chain, this is side chain, main chain. So side chain of methyl benzene forms benzyl fluoride, methyl benzene forms benzyl fluoride to form which on hydrolysis gives aromatic aldehyde. This is a conversion. Okay, next one, hydrolysis of benzyl halide. Okay, an aromatic aldehyde is obtained when benzyl fluoride is reacted with calcium hydroxide with the removal of water molecule. So we can take CHCl2. What we should take? What is we should take? An aromatic aldehyde is obtained when benzyl chloride is reacted with calcium hydroxide with the removal of water molecule. Okay, we can take first benzyl chloride. This is the benzyl chloride. What is benzyl chloride? Okay, this is benzyl chloride. Transfer calcium hydroxide H2O to form CHO benzyl aldehyde. Okay, students, and once again we can repeat. First one, oxidation of arenes. First we should take oxidation of aromatic hydrocarbons. In that oxidation of aromatic the oxidation of aromatic hydrocarbon such as toluene with manganese dioxide and sulfuric acid, benzaldehyde, and to form benzaldehyde and aromatic aldehyde. Okay, this is the toluene. In presence of manganese dioxide and sulfuric acid, H2SO4 means sulfuric acid, to form benzaldehyde. Benzaldehyde means the CHO functional group which is attached with benzene to form benzaldehyde. Okay, next one, Itard reaction. In this reaction, toluene is oxidized to aromatic aldehyde. Toluene is oxidized to aromatic aldehyde. Benzaldehyde in the presence of an oxidizing agent, chromyl chloride. Okay, this is the chromyl chloride. This chromyl chloride oxidized to methyl group to chromium complex. Okay, chromyl, what should do? Chromyl chloride oxidized with methyl group to chromium complex, which on hydrolysis gives the product. Okay, this is the toluene in presence of chromyl chloride to form chromium complex. This is a chromium complex in presence of H3O plus. So this is the benzaldehyde. Okay, this is the benzaldehyde. Next one, Gattermann-Koch reaction. Aromatic aldehydes can be prepared. Arenes are treated with a mixture of carbon monoxide. Okay, arenes are treated with a mixture of carbon monoxide and the presence of anhydrous AlCl3 and a trace of cuprous chloride. In presence of anhydrous AlCl3 and a trace of cuprous chloride, and form this is the benzene, and this is carbon monoxide and hydrogen chloride. In presence of AlCl3, aluminum trichloride, and or cuprous, this is AuCl not, this is a CuCl, to form benzaldehyde. Okay, this is a benzaldehyde in presence of and HCl, hydrogen chloride. Okay, next one, by side chain chlorination of toluene. Side chain chlorination of methyl benzene forms benzyl fluoride. Okay, side chain of chlorination. This is the toluene. Toluene means CH3 group is present. Okay, students, CH3 group is present. So in the CH3 form benzyl chloride, so which on hydrolysis gives aromatic aldehyde. So this is the toluene in presence of Cl2H2 to form benzaldehyde. Okay, this is the benzaldehyde in presence of H2O. In presence of 373 kelvins, so to form benzaldehyde. This is the benzaldehyde. And the next one, hydrolysis of benzyl halide. In an aromatic aldehyde is obtained when benzyl chloride is reacted with the calcium hydroxide with the removal of water molecule. So this is the benzyl chloride in presence of calcium hydroxide to form H2 is outside, so to form CHO, benzaldehyde is formed. Okay, students, this is the only oxidation of arenes. This is most important, and in exam point of view. So what should we do? First, we can take toluene. We know that toluene benzene which is attached with CH3 groups to form toluene. In the toluene, we can take manganese dioxide. This is the one of the reaction. Etard reaction is the one of the reaction. Gattermann-Koch reaction is the most important reaction. Why? Because it is asked in exams also. It will ask in exams also for 4 marks or maximum 4 marks, 4 or 3 marks. So we can write only definition and one structure. This structure, benzene with react with carbon monoxide and HCl, hydrogen chloride, in presence of AlCl3 to form benzaldehyde and HCl. This is enough. This is the enough. Okay. Next, students. Size of groups are substituents attached to a carbonyl group. Okay, side of groups. What is side of groups? Function groups. We know that function groups. The carbon which is attached with the functional groups is called side of groups. So, larger groups prevent the attack of nucleophiles. Okay. What is larger groups? We know that carbon atoms which is attached with hydrogen atoms, that is one carbon which is attached with three hydrogen atoms, that is the larger atom. The attack of nucleophile. Nucleophile means minus charges towards the carbonyl group. Aldehydes have only one alkyl group. Okay, aldehydes one alkyl group. Why? Because COH or C-double-bond-OH, only one alkyl group is present. Whereas ketones have two alkyl groups. So ketones means RC-double-bond-OR. Or next one is why? Because two alkyl groups means this is the ketones. Okay, this is the aldehydes. Only this have two alkyl groups. This only one alkyl group. That is the difference. To have two alkyl groups, the two alkyl groups in ketones sterically hinder the reactivity of carbonyl group. Hence aldehydes are more reactive than ketones. Okay, aldehydes are more reactive than ketones. Why? Because this have only one alkyl group, but ketones have two alkyl group. In the two alkyl group nucleophiles, two nucleophiles are attacked, but in that only one nucleophile is attacked. Nucleophile is a more electronegative atom. That's why this is a more react than ketones. Okay, students, this the order of reactivity of carbonyl compounds towards nucleophile is as follows. Okay, this is the formaldehyde. Formaldehyde means which have no alkyl group, it is present. So C-double-bond-OH. Okay, this is a formaldehyde. Next, this is RC-double-bond-OH means aldehyde. What is aldehyde? RC-double-bond-OH. Okay, this is the ketone. Why? Because RC-double-bond-OR. Okay, two alkyl groups which is ketones. One alkyl group, it is aldehyde. Without any alkyl group, it is the formaldehyde. Only that is name also stable formaldehyde. No one name is there. But in that C2H5, this is the ethanaldehyde. And this C2H5. What is this ketone? So one. What is butanone? Okay, butanone are there. Why? Because C2H5. How many C's are there in that one? For example, C2H5 double bond C2H5. Okay, student. This in this two, total 4. So 4 carbons present. What should we take? Buto. Okay, buta. This is the ketone group. Functional group is ketone. So why? What should name comes? Butanone. Okay, this is the name. What is ketone's name? Butanone. Only 4 carbons. Otherwise 3 carbons. What is propanone? 2 carbons, ethanone. Or otherwise in aldehydes 1 carbon, methanaldehyde. 2 carbons, ethanaldehyde. 3 carbons, propanaldehyde. 4 carbons, butanaldehyde. 5 carbons, pentanol. That's enough. 4 carbons enough. Also there butanone and pentanone or propanone, ethanone. So this is the. But methanone is not there. Inductive effect of the substituent groups. The effect of an atom or a group that withdraws or releases electrons is known as inductive effect. Okay, withdraws or releases. Either any reaction have that nature has withdraws or release. Any one option is there. Without option, it's nothing but in electrons and atoms and molecules. Okay, students. Atoms are groups which release electrons towards a carbon atom. That is, electron releasing groups exhibit positive inductive effect. Alkyl groups are electron releasing and thus have positive inductive effect. This positive inductive effect of an alkyl group decreases the reactivity of carbonyl group towards nucleophilic reagents. It is primarily due to the increase of electron density of carbonyl group. The ketones with the two alkyl groups exhibit greater plus inductive effect than aldehydes with none or one alkyl group. Thus ketones are reactive than aldehydes. Okay, ketones are reactive than aldehydes. In that steric group substance attached to carbonyl group, aldehydes are reactive than ketones. In that positive inductive effect, we have that ketones are more reactive than aldehydes. Okay, so this is a two also important, but this is only subject. We can know subject only. In that previous classes we discussed that inductive effect, and in first year also we discussed inductive effect. What is inductive effect, and what is mesomeric effect, and hyperconjugation. What is hyperconjugation? We know that. So these three are similar properties and similar like this. Why? Because this inductive effect also withdrawing and releasing, mesomeric also withdrawing and releasing, and hyperconjugation also withdrawing and releasing. But where that atoms are comes from, that's the point where that atoms are present. In functional groups we can use inductive mesomeric. In alkyl groups we use the mesomeric only. In alkane groups we use hyperconjugation, and that is the spirit. Why? Because in functional groups we can use both inductive and mesomeric, but only hyperconjugation not there. In alkyl groups only we can use mesomeric or not inductive. That's the fluctuations in various mesomeric, various inductive effects, and positive inductive effect is a negative inductive. Yeah, positive mesomeric and negative mesomeric. Reaction of aldehydes and ketones with ammonia and its derivatives using suitable examples. Okay, students, this is also most important. So in the topic we can discuss reaction of aldehydes and ketones with ammonia. Okay, aldehydes and ketones with ammonia reactions. What's the reactions? So that in that an aldehydes except formaldehyde. Okay, formaldehyde except means why? Which have no carbon atom is present in that formaldehyde. That's why this is not useful. Why? Because any carbon atom which is having hydrogens, so we can remove hydrogens, and in that places we can put functional groups that other vagera. But in that formaldehyde we could not take any reaction. Because why? Because this formaldehyde not have any carbon atoms. Okay, these all aldehydes except formaldehyde when treated with ammonia yield addition. Products are called aldehyde ammonia. When this addition products are treated with dilute acids. Okay, this addition products are treated with the dilute acids. They give back the aldehydes. Okay, they gives aldehydes. Hence this reaction is also known as in the separation and purification of aldehydes. Okay, this reaction is also useful in separation and purification of aldehydes. Okay, this is acetaldehyde. Why? Because this only one carbon atom is present. This is acetaldehyde in presence of ammonia. This is ammonia to form acetaldehyde ammonia. Okay, this is acetaldehyde ammonia. Okay, next one. When formaldehyde and ketones are treated with ammonia. Okay, formaldehyde and ketones are treated with ammonia. In that, when formaldehyde and ketones are treated with ammonia, so they form complex condensation products rather than addition products. Okay, in this acetone, 2 moles of acetone in presence of ammonia to form, what is this? We can take 2 moles of ammonia, 2 moles of acetic acetone. Okay, this is the acetone. One means ketone group is present. Okay, in that ketone group CH3 C double bond for CH3 plus NH3. So in that CH3 CH3 NH2 CH2 C double bond for CH3. Where did it comes? Okay, students listen. CH3 C double bond for CH3 plus CH3, C double bond for CH3. So not mentioned. So NH3. In that NH3, where it goes in this H atom, you can take C double bond O H atom. So in that O atom, in that H, so H2 is outside. Okay, H2 is outside. In that O, we can replace NH2, CH3, CH3. The CH3 gets this side. So in that NH2 comes. So CH2, C double bond O CH3. Okay, these are students. So we can take 2 moles of acetone. Okay, 2 moles of acetone means CH3, C double bond CH3 and CH3, C double bond CH3 plus NH3. Okay, in that students we can remove in that H atom. Okay, one H atom. In that where did it in that also one H atom. Take that one H and this two H's. These two H's combined with the O molecule to form H2. Okay, in that H2, okay, in that double bond is break and O molecule O minus is attached with these two H atoms to form H2O. Okay, this H2O. So in that only CH3 single bond, this NH2 comes this side. So the CH3, this NH2, this CH2, okay, this CH2. Why? Because in that one atom is removed, H atom. So CH2, C double bond for CH3. So this is the diacetonamine. This is the diacetonamine. Why? Because diacetone, di means two, secondary, diacetone amine. Amine means this. This is the diacetone amine. Okay. Next one. When the bisulfide compounds are heated with the dilute acids. Okay, bisulfide compounds means sulfide SO4 combination or SO3 combination. Dilute acids or bases, they give back the. Therefore, this reaction is used in the separation and purification of carbonyl compounds. This reaction only used in separation and purification of carbonyl compounds. In that CH3C OH SO3Na CH3. Okay, this is the bisulfonate compounds in presence of HCl to form CH3CO CH3. This is the diacetone. What is this? Dimethyl acetone. Okay, in presence of NaCl to form NaCl, sodium chloride and SO2 plus H2. Okay, student. This reaction with the hydrogen cyanide. Hydrogen cyanide means HCl. HCl. So in this hydrogen cyanide, the carbonyl group of aldehydes and ketones adds up hydrogen cyanide to form cyanohydride. To form cyanohydride is carried out by treating a carbonyl compound. With sodium or potassium cyanide. And a dilute mineral acid. Dilute mineral acid as HCl cannot be used directly. Because of its toxicity. The cyanohydrins formed can be hydrolyzed to obtain carboxylic acids. So in that carboxylic acids, double bond O plus HCl to form H2OH plus C OH COOH alpha hydroxy acid. Okay, that what is carbonyl compound. Okay, this carbonyl compound in presence of hydrogen cyanide to form cyanohydrin. Okay, this is the cyanohydrin. Why? Because COH in that N. Okay, cyanohydrin CN. This is the CN to form in presence of H2. Okay, students, you can take the actual. Okay, what is this carbonyl compound? C double bond 4. Okay, this is carbonyl compounds plus HCl. Okay, this H go to this side, this double bond is breaking, so CO minus plus HCl. Okay, in that negative charge is there, so in the negative charge we can take positive charge H plus. This H plus goes to this side, so what happens? OH. Okay, this OH, what is this? Only remaining this Cl molecule. So this is the, what is this? Cyanohydrin. Okay, this is cyanohydrin. In presence of cyanohydrin, H2O plus H2O, what is water molecule? So to form COH, this is same, but in that cyano, this H2O is combination to form COOH. So this is the, what is this? Alpha hydroxy acid. Okay, this is alpha hydroxy acid. Why? Because this is in first position, so we can take alpha. At second position beta, third position gamma. So this is a first position alpha hydroxy acid. Okay, students, for example, we can take CH3 C double bond bond H. Okay, plus HCl. What is this? Acetaldehyde. Okay, this is acetaldehyde. In presence of H2SO4, we can take CH3 COH CnOH. Okay, in that in presence of H2O to form CH3 CH COOH OH. Okay, student, listen. In presence of acetaldehyde, in presence of HCN to form, what's this? Acetaldehyde cyanohydrin. Okay, acetaldehyde cyanohydrin. Okay, in presence of H2O to form, this is the lactic acid. Okay, this is lactic acid. Okay, next one, benzaldehyde in presence of hydrogen cyanide to form this is benzaldehyde in presence of HCN to form mandilonitrile. Okay, this is mandilonitrile. Okay, next one, third one, what is this? CH4 CH3 C double bond 4 CH3. This is called acetone. We know that, students. Acetone in presence of HCN to form, what is? Previous also we discussed last two reactions. What is this? Acetone in presence of HCN to form, what is this? CH3 COH CN CH3. Okay, this is acetone cyanohydrin. Acetone cyanohydrin. This is acetone cyanohydrin. Okay, student, this is the reaction with the cyanide. Okay, this is the reaction with the cyanide reactions. Okay, first one, we can take the carbon group of aldehydes and ketones adds up hydrogen cyanide. Okay, to form cyanohydrins. It is carried out by treating a carbonyl compound. Okay, carbonyl compound with sodium or potassium cyanide and dilute minerals as HCN cannot be used directly because of its toxicity, okay, because of its toxicity. So the cyanohydrins formed can be hydrolyzed to carboxylic acid. So this is the carbonyl group, this is the hydrogen cyanide, so to form cyanohydrin, okay, in presence of H2O to form alpha hydroxy acid, okay. In that example, first one acetaldehyde, CH3 C11H, okay. In that HCN, in presence of H2SO4 to form acetaldehyde cyanohydrin. Why? Because this H molecule combined with H O molecule to form H2 is outside. So in that HCN, CN comes to this side, okay. Why? Because C plus is formed, carbocation is formed. So in that carbocations we can feel negative charge. Negative charge, what is negative charge? Cn molecule. So Cn molecules combined with the carbocation, okay, is the level base. Next one H2, and pens of H2O and pens of delta to form lactic acid. This is the lactic acid, CH3 CH C double bond COOH OH. This is lactic acid, okay. Next one benzaldehyde. Benzaldehyde means this benzaldehyde in presence of HCN to form manganylonitrile, okay. This is manganylonitrile means this is a flame work in labs. So this is not useful for labs in second year. You are not use this. Only this is used in MSc or PhD students, okay. You need not to study this second option because manganylonitrile is not. So third one acetone and in presence of HCN to form acetone cyanohydrin, okay, to form acetone cyanohydrin. Next one mechanism. Initially the base extracts proton from HCN resulting in the formation of ion. This ion's nucleophile and attacks the positively charged carbon to form an ion HCN plus OH to form H2O, okay. This H combined with OH to form H2O. The Cn molecule is a variant, okay. The Cn minus plus CO. What is CO? Carbonyl compounds. So to form cyanocarbonide, okay. This is the cyanocarbonide, okay. Next one, in the next step, proton from the solvent attacks the negatively charged oxygen atom to form cyanohydrin. So this is the cyanohydrin in presence of H to form cyanohydrin, okay. So in this CH3 CH4 acetaldehyde in presence of hydrogen NH2 NH2. In this in this H2O outside, H2O water molecule outside. So acetaldehyde hydrogen. This is the acetaldehyde hydrogen. What is acetaldehyde hydrogen? So CH3 CHO, okay. This is acetaldehyde, okay, plus NH2. This is a hydrogen. So in presence of H to form this H combination with H2O. So CH3 CH double bond and H2. Acetaldehyde hydrogen. Next one CH3CO CH3 plus NH2 and H2. This acetone, okay. This is the acetone in presence of hydrogen. H2 CH3 double bond and H2. This is aldehyde group. This is ketone group. In this aldehyde groups to form in presence of ammonia hydrogen to form acetaldehyde hydrogen. In this ketone group in presence of hydrogen to form, what is this? Acetone hydrogen, okay. Acetone hydrogen, okay. And the next one, aldehydes and ketones react with phenyl hydrogen. Phenyl hydrogen means C6H5. Phenyl means, so to give phenyl hydrogens, okay, phenyl hydrogens in this C double bond O plus NH2 NH C6H5 gives rise to, this is addition product. Why? Because two or more atoms present in that compound, so this is addition reactions, complex reaction otherwise. So in this complex reaction we can take H2O molecule, add with H2O molecule to form phenyl hydrazone. Okay, this is what is this? Aldehydes and ketones react with phenyl hydrogen carbonyl group. This is a carbonyl group plus NH2 NHC6H5. This is the phenyl hydrogen. Okay, in terms of so COH plus NHC6H5. okay, in terms of H2O, C double bond N NH C6H5. okay, this is the phenyl hydrazone. Phenyl hydrazone. Example: this is a benzaldehyde, phenyl hydrazone, phenyl hydrazone plus H2O, phenyl hydrazone plus H2O. Next one, reaction with semi-carbazide gives semi-carbazone. So C double bond O plus NH2 NHCO NH2. This is semi-carbazide. Okay, semi-carbazide. The semi-carbazide you can take addition product. Okay, this is also the H2O in presence of H2O to form semi-carbazone. Okay, this is a semi-carbazone. Same, but in this structure is different. NH2 NHCO NH2. Okay, example CH3COH acetaldehyde in presence of semi-carbazide to form acetaldehyde semi-carbazone. Okay, students, where we taken, that's the name came in that acetaldehyde and semi-carbazide to form acetaldehyde semi-carbazone. Okay, this is this one.